So good morning, good afternoon, wherever you are. This is the third talk of my three, and I'll be talking about two things. Oh, hang on, I'm doing the wrong thing. I immediately proposed. Let me get my head together. I immediately proposed that we were going to delay that. So let me delay that, and let me bring up the exam paper that I proposed to look at. A little note to the organisers. I did suggest that I might not do this one because I'd already annotated it, but I must confess that I'm feeling a little bit insecure about going through an exam paper cold. So I'm going to chicken out and I'm going to look at this one that I've already annotated, and perhaps having the annotations in it will help some of the people. So the one I'm going to look at is one from the university. For an introductory program subject, and of course the acronyms don't mean much to me, but I'm sure they mean something to the people from that university. An exam they did back in 2020. Now I made a little note. All my notes are in these yellow boxes, and what I do is, I've talked about this before, I tend to be an old-fashioned kind of a guy who uses the old taxonomy. And its ordering was knowledge, comprehension, application, analysis, synthesis, evaluation. The new one, which came out in 2001, made some changes. Some of the changes were to just the names of the categories. They changed from nouns to verbs because it's thought in education circles it's better to talk about what the student does, hence the verb. So knowledge is still the same. It's just known by new name, remember. Comprehension is the same. It's just now called understand. Application is changed from noun to a verb, apply. Analysis becomes a verb, analyze. The single biggest difference is here at the top, and I don't think it's a very big difference. The top two layers, the top two levels have been swapped over in the new taxonomy. The argument being that that creating stuff should be at the top. Okay, so synthesis, which was second on the list in the old taxonomy, is renamed creating, is promoted to the top, and evaluation is moved down to second place because the people who do the revision felt that people should be able to evaluate something before they could create it well. And of course, in the process, they changed it from a noun to a verb. I think in most of my annotations, I use both terms. So that you'll find I use the old term followed by the new term, so that if you're familiar with one or the other, you should be able to follow it. That doesn't really apply here. My comments below assume that the reader has heard my previous two talks. Well, the odds are that if you're still with us today, then you have heard my two earlier talks. So let's move on. And by the way, organisers in particular, please, if you think I'm being too fast or something like that, please pull me up, slow me down. So here we come to question one. Now, I'm very conscious that I've read through this paper already, and I've spent more time reading it than I'm about to spend reading it now. And that's a problem for you because you might feel a need to go through the whole thing. We don't really have time to read every word, so I'll try to give you a summary of what I think each question is about. And if that's not enough, by all means, somebody should pipe up and tell me that they need to know more. But so the questions here are following. Well, the first ones are just, are they true or false? So an integer can be implicitly converted to a floating data type. Every Java statement must be terminated with semicolon. A for loop is an example of a selection control structure. And then the next few are multiple choice with 4 options. So what is the importance of importing a class into an application? Blah, 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 blah. And one of those presumably is correct. What is the static method? I think I showed that on Monday's talk. That's one of the questions. Now, I won't go through, at least I won't go down through every single one of these. For question one, as I've written in my comments, I think most parts of this, if not all, we'll get to that in a second, are at the knowledge level in the old terminology, or the remember category in the revision, the bottom category. Now, as I've written, you might reasonably argue that 1.4, this one here, goes beyond knowledge a little bit because it asks what is the importance of importing a class. So you might argue that we're going that little bit further than knowledge, and we're asking the student to demonstrate their understanding of the significance of importing. I think you can make that argument, and I won't fight you on that, but I will stay with knowledge because, as I've written here, I suspect that remembering is the major psychological process involved here, rather than translating the question into some sort of a different form to answer it. I think it's mostly about remembering. But if you want to object, that's fine. I mean, it will come down to, we can follow definitions and tick them off, and that way we can arrive at black and white decisions. For example, if we agree that remembering is the major psychological process, then yes, this is a knowledge question. 1.4 is a knowledge question. If you want to debate that, I think you're free to, particularly as Bloom says this himself. You've got to remember that you're always applying this in a certain context, and you, the teachers, know what your students know and what they don't know, and therefore, on the basis of your superior knowledge of the students at this university, you might say, no, this is not a knowledge question because we didn't really give them in that form. It's comprehension. By all means, make those sort of arguments. I'm going to scroll down. If anybody, particularly the organisers, want to jump in at this point and want me to elaborate on anything to do with that, I can. I'm going to say that the rest of these are mostly, I still think, are categorized. What did I categorize everything as? Is knowledge. What is JDK, an environment? It is Java and so on. I think that's knowledge. At least from this distance, it appears to be knowledge. As I've said, you might argue that it's a little bit different because of the circumstances of your teaching. I want to highlight this one piece out of 1.9. Peter has just learned about the concept of pre and post incrementing. He comes across a piece of code that displays the value of X as follows. And here's a print statement. The value of X is, if the value of X is 10, what will be the output? It's not clear here, by the way. I'm sorry, I'm being a teacher for a moment, not a researcher. If the value of X is 10, do they mean the value of X is 10 before the print statement or after the print statement? Slight ambiguity in the question, but I will assume that they mean if the value in X is 10 before the print statement. And I have gone with knowledge/remember again for this question. Now, as I've written here, you might argue that this question is comprehension, because technically you could say that realizing what's going on here is technically tracing the code. You can argue that, particularly if you know better about your teaching environment. But I'm going to stay with knowledge and remembering for this one, because I'll stay with that quote from earlier. Remembering is the major psychological process here. I think the thing that the student has to remember is what the auto increment does when it's in front of the variable name, and I think that's more knowledge than a tracing problem. My apologies if the exam writer is here and I've just critiqued your question by saying I thought that was a little bit ambiguous. My apologies, but we do that all the time to each other, don't we? It's almost cruel. So code reading exercises, question 2. And by the way, I remind you, particularly the organisers, if you want me to jump in and you want me to stop and elaborate on something, please pull me up. Now, Lutendo is running a small cinema business in Sosh. Please forgive my pronunciations, which I'm sure are all wrong. She only allows people who are 18 years and above entry into a cinema. Looking at the given code snippet below, which code is missing at A? Now, the thing is, okay, here's our code, and then there's a missing line here. And then crucially, we are not asked to write that line of code. We are asked to select from a series of options given to us. And on that basis, I'm going to argue that all the necessary information to answer the question has been supplied, and our job is simply to, out of the distractors, eliminate the distractors and choose the correct one. And that, for me, makes this a comprehension/understand problem. All the necessary information has been provided. The student's been given everything, including the correct alternative. I argue against, and I probably will be skipping over the other ones, which are very similar. Well, we might say a little bit about that in a second, but they're very similar. Something's missing, and it's a multiple choice question where you are asked to select the correct one. I argue against any having any of these parts. This is 2.1 and the others that I just scrolled down to briefly just now. I'll argue against having them at a higher level, since all the necessary information is provided explicitly, including the correct alternative. I mean, in theory, it's hard to, yeah, let's leave it at that. If the student has not been given alternatives, but instead was asked to write the correct solution for themselves, then that would be a question at the application/apply level. Now, unless anybody's going to pull me up and either tell me I'm wrong or tell me that they need to process this a bit more, I shall move down to the next part. I hear a microphone there. Is that just somebody who happens to have the microphone on, or they want to say something? Nobody's speaking up, so it was just a microphone was on. Okay, this is the second one, 2.2, and I'm not going to say much about this because I'm going to classify it the same as before. We are given, in this case, 2 places where pieces of code are missing, and then we're given multiple choice options where we are given, the code that could go in those 2 places. Now, on Monday, when I talked about this, I said, probably you only really want to have 1 line of code missing, because as soon as you start talking about 2 and 3 and 4 and 5, eventually you must get to a point where it's just too hard. And so much code is missing, you're almost asking the student to write the whole thing. Yes, there is that gray area. How much missing code changes the nature of the question? I'm going to argue that in this particular case, with these 2 lines missing, it hasn't moved up beyond comprehension, particularly as in some sense the 2 lines are a little bit independent of each other. They don't interact too heavily. But so I'm going to stay with comprehension and understand for this question. Another issue I think which perhaps I could have added an annotation to is there's quite a lot more code now. Some of it's what some of us call boilerplate code. You've just got to declare various things. You've got to do some inputting and so on. So I'm going to argue that this code it doesn't really, just sets things up, and it doesn't complicate the thinking too much about what's going on here and here. So that's my classification. I'm staying with comprehension understanding until you come for me with burning torches to tell me I've got it wrong. Once more, this is quite a lot of code, and I'll confess I haven't read through all this code. So if somebody has and they want to pick me up on this, I see 1 line missing, is that right? And it's a while condition, and we've got to choose the correct condition to run this loop. So a lot of this code, again, is just setting things up, and the student doesn't have to process it too badly. They just need to understand, they just need to process what's going on in the while loop and why the while loop should stop. So again, I'm going to go with stay with comprehension and understanding. Now, I'm sure that if I tried to pronounce that name, I would get it wrong, so I won't. Best I could do would be AO, but I'm sure that's wrong. I apologize in public this time. I've done this before. For example, Bertie, I know I make a mess of pronouncing your name. I wish I could do better. AO wants to create a static method that will determine and return the sum of 2 numbers. Which of the following methods headers is most appropriate? Interesting. They're method headers. So in a sense, there's no moving code. There's no code where variables are being, values are moving around. There's no algorithm as such. It's a header. And I would argue that means that it's not, reading this line of code is not really an exercise in tracing. Reading these lines is an exercise in applying your knowledge of what the various parts mean. Public doesn't matter too much because it's the same in every case. Clearly some are static and some are not, so you have to understand what static means. And I know I'm using the understand word, but I should avoid that word. Maybe I should stick with in your knowledge base, you need to know what static means and what it means to leave it out. In your knowledge base, you need to understand what it means for it to be void, and or to return in, and so on. Now, you could argue that, the question has been set up here, and the student is being required to take this English level description and recognize the correct implementation of that in Java. And therefore, you could argue that there is a translation exercise going on from English to code, and therefore that puts it in the the comprehension/understand category, the second highest category, second lowest category. You could make that argument. And I've said if you use the same reasoning as I've described above, you might put it into that category, comprehension, understand. However, I'm going to argue that I think, again, remembering is the major psychological process involved here. Not so much the translation from that to this. I think it's more remembering. But again, you may know better with your students and how they've been taught this stuff. And you therefore may want to argue that it's comprehension/understand. And I don't think I need to say, I'd just be repeating myself. I think if I talked about that one, it's substantially the same sort of issues as that one. Then we get to the IPO chart. And as I'll say in my comment, I'm flying a little bit blind here because I must confess I've never used IPO charts, either in my own programming or as in teaching. So bear that in mind as I offer up a suggestion on what's going on here. I could be wrong. So we have a triangle, and it's explained how the area and perimeter of a triangle would be calculated. And further down, to do, create an IPO chart that will determine and display both the area and perimeter of a triangle. Given to you below is table 1. The table has possible answers that you can use to complete. Okay, right. So it's like a bit like a multiple choice question. We've been given a bunch of things and we need to choose. It's not like we have to write the IPO from scratch for ourselves, which may involve some realizing certain abstractions are required. We're being told the alternatives. On the other hand, there's a lot of alternatives, and just being given them as a list may not be a big help. We'll see as we read a bit more of the question. Each possible answer is represented by a letter. Yep. So I think the student is being told, you don't have to write the whole thing, just write a letter. And then we come down to the part where the student has to fill in the correct letters. And I see that some have already been done for them. I think that's what that means. Or no, hang on, no, that's the variable name, is it? I shall butt out of that now in case I've got it wrong. But I think the student is required to write in all these places a letter corresponding to one of these things up here. Now, as I said, I haven't used IPO charts, so maybe I misunderstand what they do. I'm on the basis of what I do understand, I'm going to go for comprehension/understand. The student is required to translate or interpret from English to that IPO. And by dint of the fact that there's just so much information supplied, I'm going to say it gets a little bit beyond knowledge and it gets into the comprehension/understand category. And as I said, I'm prepared to accept that I may be wrong because of my limited knowledge of IPOs. Then we get to the flowchart implementation. And I've put my comment early, but let's go down through the question, then we'll come back to it. I think that we don't need to know too much about the actual problem being solved to do the Bloom classification. I did read through it, but I think that when I did my classification, but for the purpose of this presentation, I don't think we have to go through it in detail. I think what we do have to do is just admire the flowchart, if you like, and get an overall feel for how complicated the flowchart is. So there it is. We get down to a decision, and if this decision is true, we go here, and false, we go here. So we've got an if. This would be like an if-else condition going on there, and then we come down further, and we have to go to the next page to see the rest of the flowchart. So we come back together after all that, and we do a couple of other things. And do you want to play again? And you get the answer, and if the person says yes, there's going to be a great big loop that takes us back up towards the start. So there are a few things going on. And I did say on Monday that, definitely a simple flow chart is in the comprehension/understand level. And it's possible that a very complicated flowchart where you've really got to work hard at mapping from flowchart to the say nested conditions of code that could push you up. But I'm going to argue that this flowchart is not so complicated that it pushes it above comprehension/understand. Let's see if that's what I said. Okay, question 4, the flowchart question. Yes, I put it in a comprehension understand. The student is required to perform a translation. If you do remember Monday's discussion, I was very big on this word translation. If you translate from one formalism or English, so an unformalism if you like, and you translate to something else and all the necessary information is provided, that just about guarantees that you're talking about comprehension understand. The flowchart is a well-defined form of communication that explicitly provides all the necessary information. It's a big flowchart and therefore a difficult comprehension question, but difficulty doesn't really change the Bloom level. And I think this is a problem that most people have when they first come to Bloom. You can have a difficult comprehension understand question. You can have an easy application question. Difficulty is a secondary consideration when it comes to assigning. In general, more difficult problems will rise up through the hierarchy, but sometimes questions are just difficult because they're long, they're difficult because they have a lot of detail. That doesn't necessarily push them up to a higher category. So that's what I'm going to stay with, because the flowchart supplies all the necessary information and it's not an obscenely complicated flowchart. I'm going to stay with comprehension understand. You could ask me, well, suppose we made it more complicated. At what point would you move it up to a higher category? Well, I'd have to say to you that, you know, you've heard the old expression, it's very hard to define the difference between art or pornography, but, you know, I know which one I'm looking at any one time. Likewise, I don't think that there are very general principles that will allow you to, with absolute clarity, apply with the general principles, and they'll always tell you, you know, what level you're at. Sometimes you've just got to look at the question. So I'm going to try to escape that accusation of just how much more complicated would this have to get by saying, well, show me a flow chart and I'll tell you whether I think it's too complicated. Problem solving. Okay, the problem statement. Two countries A and B are on the same timeline. The only difference is that one has a 12-hour clock and the other has a 24-hour clock. And then we're told to create an application that converts the times and allow a person in country B to know what time it is in country A. You can probably stop reading the details at this point. I did read through it earlier just to make sure, but I think for your purposes, we can stop at that. We've got to convert from a 12-hour to a 24-hour. And then an example was given. You have to create the application, you, the student. So what did I say? I went for application and apply. So I've moved up from comprehension understanding to the next, into the middle layer. Remember that as far as I'm concerned, that, well, as Bloom says, the 6 levels form 3 pairs. So knowledge and understanding, those bottom 2 categories form a pair, and now we've moved up beyond those to the middle categories, the first of the middle categories, application in the old terminology or apply in the new terminology. So why not? And as I said on Monday, the middle categories tend to be defined in terms of how they differ from the other categories, from the bottom categories and the top categories. So that's why I've gone for a different way of writing now for this. Is why is it not comprehension? Because all the necessary information is not explicitly provided. I certainly haven't given an algorithm. So I don't think it's necessarily a complicated algorithm for how to do it. It's not like where the Ipo chart stuff was given and so on. It's not a complicated algorithm, so I'm thinking this is not a difficult application/apply question. But nevertheless, I think it is application apply. It's a relatively easy application apply. Why not synthesis? Because I don't think that there's enough scope for creativity. If you're worried about this C word, creativity, just say, you know, you're marking the exam papers. How many qualitatively different correct solutions do you expect to see? So firstly, how many, you know, throw away there's infinite creativity for wrong answers. So let's ignore the wrong answers. Let's stick to just the right answers. Could you put them into a series of piles where you say, well, there's a few minor differences between I'm holding two solutions. There are some very minor differences, but I regard them as essentially the same algorithm, the same thing. So I'll put them in the same pile. And you do that, so you come across another one which is, well, actually this one's quite different from the first two. It's correct, but it's quite different. So I'll put it in its own pile. How many piles do you end up with? If it's a small number of piles, it's application and apply category. If it's a very large number of piles, in fact, if every solution is just about different, then you're moving up into the synthesis create area. Now, inevitably, somebody could ask me, well, at what point? How many piles do you need before it stops being application and apply? And I shall say, you show me the question, you show me the piles, and I'll tell you. I'm not going to offer up a general opinion on that one. Oh, and then I put this, we had a debate about this on Monday, so I really should talk about this again. And I did kind of qualify what I initially said. As a rule of thumb, I suggest that it's difficult to give students synthesis create level questions in a written exam. This is the bit I added after Monday's talk. In a traditional exam like this one, where you've got students doing all sorts of questions, it's very hard, I think, to give them one that requires synthesis and create. But I agree with you after we discussed this on Monday. If you give students 3 hours to write a program, then it's fair to say that you could certainly ask a synthesis create question then. That seems quite reasonable to me. And I'll go back to my, different piles. If you took all the correct answers, you'll get substantially correct answers that the students gave you, and you started putting them into piles about how they differ, qualitatively. If you end up with a lot of piles, then it's synthesis/create. And then question 6, project coding. Koos, my apologies to anyone called Koos who might be listening. I'm sure I got that wrong. Is a property owner in Kempton Park. That part I can pronounce. He rents out his houses mainly to families because of this. Okay, Koos wants an application that will help you anticipate the water bill. Okay, for a house. Okay. Probably I have read through the words. Probably don't need to go through them. I think what we have to do is admire the complexity of what's involved in making the decision about how to price. It's quite a big table here. I can't say I've read every line of this. I just have admired the amount of detail in it. And it's on that basis. I haven't sat down and written a solution, so I could be wrong about this. On that basis, as I said, this is a tough one. I think I'll classify, having misspelled classify, it as application, apply, but with reservations. So again, I put it in the middle category, one of the middle categories. And generally, we define the middle categories in terms of how they differ from the bottom and the top categories. So again, why not comprehension and understand? Because I'll argue, at least from my understanding of what I have read in that table, that the necessary information is not explicitly provided. You might argue that table 1 does provide all the necessary information, but I'm going to argue that it's provided in such a way that it doesn't map easily to a set of nested conditions in code. That's my argument based upon my reading of it. If you may have a better appreciation, particularly if you've seen a sample solution, you may have a better appreciation. And if you argue separately, I'm not going to fight you. I'm just going to stay with my conviction that mapping from table 1 to the code is non-trivial, and therefore all the necessary information is provided. And therefore is not true, and therefore not all the necessary information is provided. Yeah. Why not synthesis and create? Well, as complicated as table 1 is, I don't think it leads to a great deal of creativity in solutions. I wouldn't expect to see, if I put qualitatively correct but qualitatively different solutions into different piles, I wouldn't expect to see many piles, if any. But if you showed me the actual student answers from a class and there were an awful lot of piles, I'm not going to try to find how many crosses the threshold to be an awful lot. Then I might change my mind. And then finally, I just repeated what I said in the previous question. As a rule of thumb, I don't think you can really ask synthesis and create questions in a written exam, and that rule of thumb has guided me to some extent in these last two questions. Guys seem to have, you most certainly could ask a synthesis create question in that environment. And I think that was the last question. I mean, there's a great deal more information provided on how that one works, but I think the critical information was what I'd already been through up here. So that, I think, was the last question, wasn't it? Does anybody want to take me up either on any one question, or do they want to ask a more broad question that rises from looking at these questions? I'm just going to stay silent for a moment to see if anybody wants to speak up.
Bertie, you can take the chats.
Yes, Professor, we had a question from somebody that asked, will difficulty be associated to the type of assessment? Meaning, should a class test be considered in the same level as, for example, in an exam? Or, yeah, that's basically, if you do a class test, the educational value of it, should it be on a more lower level class test, or should they also include more detailed type of questions? I hope I understand that question correctly, but I think I interpreted fine.
Okay, I think that the question is about the educational value of testing at different levels. I'll actually won't answer that question. I'll do a preamble answer first to a slightly different question. And that is, effectively, please understand I'm kind of deliberately misunderstanding your question for a moment. I'm answering a slightly different one. That is, the context, in a sense, doesn't matter. I mean, if you forget about the educational value of things, if you show me a question and I have to classify it, it doesn't really matter whether it's in a test in the middle of the semester or it's in the final exam. Oh, well, let's put it this way. If it's a mid-semester test, then the students know less at mid-semester than they know by the end of semester. So in that sense, you've always got to make judgments about questions on the basis of what you know the students know. So only in that restricted sense could a question potentially change categories between mid-semester and the end of semester. But in general, I don't think they do. So now let's get back to what I think the question was, as Bertie phrased it, and we might get. By the way, can I just explain that when I throw up my screen mode I can't see your chat window, so that's why I don't respond to you as you type questions. That's why Bertie's doing the good work of looking at them for me. The educational value. I'm tempted. Well, let's take my researcher hat off for a second, and even my Bloom hat off for a second. I don't want to speak with authority on that issue. I just want to speak as one colleague to another, one teacher to another. I think that we want to, and we're talking about the mid-semester, and let's say it counts for very little. We have to make it count for a small percentage of the final, score of a student at the end of semester. It has to count, say, 5% to their final grade or whatever, because otherwise the students won't do it, or they certainly won't try to. So we attach that, but as teachers, we know that 5% is neither here nor there really, and so we're effectively doing it as an exercise in helping the students to learn or encouraging them to learn. So what's the best sort of questions to give in that situation? Well, you said the word test, I think, in your question. I can't see the chat window, so I can't verify that. You said a test, so I'm going to say you're not setting anything at the synthesis evaluation level, and what is a relatively small test, I think. My view of those sort of tests is that they have two functions: is to help the student learn, and the other one is diagnostic. You get to find out what the class, where the class as a whole is, and where individual students are in their learning. So I would be inclined to give a bunch of questions, if it's possible, if you have the time. Certainly at the comprehension, possibly at the knowledge level. I usually never have many knowledge questions. So I usually start at comprehension and understand. Certainly there, and certainly at the apply application level. Maybe if I can think of something, I'll do something at the analysis level. And I'll have a range of questions so that I can get a spread and see where the class is. Usually the sad truth is that you find out that everybody's down at the comprehension level, and you have very few students. Mike McCracken's Picasso's might be up there doing the other ones, but the great bulk of your students are down at that comprehension level. Is that an answer to the question?
Yes, I think it is, and it's wonderfully stated. Our next question that we have is, if we look at the missing code fractions, then the person asks, I suppose the more code in these instances raises the difficulty level, not the cognitive level. And I think that's something that you really emphasize, Prof. Raymond, is that there's the difficulty level and the cognitive level is two different things. And linked to that same question, there was somebody that asked, is there something like Bloom's taxonomy for determining the difficulty level, or a combination thereof, or something like that? I mean, we did look at the solo taxonomy, but anything in that regard?
Yeah, okay. The difficulty, I will say I'm not sure. That's the short answer. I'll suggest somewhere you might go to see if it would help, and that is the Revised Taxonomy. The original Bloom's taxonomy is this one-dimensional set of levels, the 6 levels. And I'd have to say, and this is not a criticism of the revision, I think that the changes made on that dimension, the changes to the names from nouns to verbs, the switching of evaluate and create, are not that important. But the really substantial change / addition that the revision, the revising people made, was they added a whole second dimension, where for each of these levels, they then go on to talk about, it's like a table. Imagine, I can't bring it up, but I'm sure that one of you can find it when you do some Googling. You've got a table where as you go down the table, you move through the levels as we know them. And then across the page are a series of columns with titles describe cognitive processes that students have to do of different types for a problem, potentially for a problem at the levels that we are talking about. That might be a good place to go. Let me try to, apart from the fact that I think the changes to the names in the dimension that we are talking about was for me, it's more of a nuisance than anything else. For you guys who've learnt Bloom after 2001 and you've learned it from the revision, no problem. But for an old fogey like me who learned it before then, I'm never sure which set of words to use. I think better than the old one, and then I have to translate when I talk to people who know the revision. What was my point? Oh, and I've found that over the years, as you people are finding, it's hard enough for people to come to a consensus on these 6 levels, how to classify questions in the 6 levels. So I just put the second dimension of the revision in the too hard basket for myself. I've not worried about it for that reason. However, well, there's another reason, but I won't go into it. You guys who are really worried about this issue of difficulty, they're in the revised taxonomy in that second dimension may be the answer to your problems. I don't know, because I don't know the second dimension very well, but it's worth looking at. I think that's all I've got to say about it.
Thanks. And then we've got another question. Does multi-select question qualify as an attempt to raise the difficulty level? Yesterday, we spoke about types of questions, and Prof gave it a specific name where we had that type of ordering and multi-select type of questions. So the question is, does these type of questions attempt to raise the difficulty level?
So I'm sorry, I think you were quoting me just then. I think Bertie's having said something yesterday, but I'm not clear what it is that I said. What do we mean by multi-select? Is that like where you've got a series of lines of code and you have to put them in the correct order? Or is that something else?
That's one of them. And then the other one is selecting all the possible options that could apply to a particular to a particular term, to a particular concept. So it's like a multiple choice question, and Hannes can come in here if he wants to speak. It's like a multiple choice question where there can be more than one particular correct answer to the question, but it's not just limited to 4. It can be 7 or 8 different.
Oh, I see. Okay. Again, of course, to give you an authoritative answer, an answer with great conviction, I'd say, show me the question. But let's talk in general. In general, if we're talking about a multiple choice where there's more than, say, 4 or 5 options, 4 or 5 is very typical. Let's just for argument's sake say there are 10 options. I don't think that changes the level. I still think somewhere in those 10 options there are 9 distractors and there's 1 correct answer. And you are putting a cognitive demand on the working memory of a student, I suppose, by getting them to sort of compare questions and decide how they differ, and options and decide how they differ, and then eventually arrive at the correct one. But I don't think that issue changes the bloom level. That's my suggestion on that.
Sorry, it's my question. May I ask something about that?
Sure.
I've had many years of asking multiple choice questions and that type of stuff, and I found that the pass rate goes down the moment I change my multiple choice to multi-select. Even in my multiple choice, the moment I add a none of the above, all of the above option, then the whole ball game, it's as if it changes for the student. And there is an observation of a drop in pass rate. Should that not be seen as a difficulty level incline?
Well, I'm not going to answer with great conviction. What I think I've seen something similar. I know what you mean. I used to add none of the above. I used to have 4 good, what I thought were 1 correct solution, 3 good options, and then I'd add as a 5th option at the bottom, none of the above. And the principal reason why I did it was because if I made a mistake in writing the question, then none of the above usually meant that I could salvage the question. So that's a very pragmatic reason for doing it.
But that's with 1 correct answer. Multi-select means there's more than 1 correct answer. So it's a combination of answers that makes it correct.
I won't answer with great conviction, but I'll put my hunch to you, which is that multiple choice questions are quite effective, but there is considerable scope for game playing, where a student doesn't really know the answer, but they can apply certain principles, certain heuristics to give themselves a fair chance. Like you can almost always eliminate 1 option. It's just a bit silly. The examiner ran out of ideas for distractors, and there's one that's a bit silly. And there's all sorts of other ones that you may know of. When in doubt, go for option C, because there is a psychological tendency to bury the for people writing questions, to bury the correct answer among the distractors and not have it at the top or the bottom. Sometimes it's the longest answer. There's all sorts of ways that students can gameplay the system, and exams are like a Turing test. We ask a series of questions of the student, and then we listen to we read the answers to decide if there's any intelligence involved in the answers. I say that slightly facetiously, but I think it is a good comparison. And so in the Turing test, the computer is trying to fool you into believing that it's a person. Equally, the student in this game is trying to convince you they know something when they don't. And so the game playing, I think, is why you see your scores going down, because the more options you offer, particularly if more than 1 is right, if you add things like all of the above and none of the above, I think you make it harder for some students to play the game. But I don't say that with great conviction. That's the best I think I can do, as one colleague to another.
Thanks.
How does that sound to you? Or would you disagree? Oh, and I should add, to actually specifically answer your question, because I think it's mostly about game playing, I don't think it changes the bloom level. Sorry, how does that, do you want to disagree with that and just say a few words, or?
I don't know. At the end of the day, we use Bloom to determine the overall ability of the student to answer the questions and how difficult they will find it to attend. So I don't know. I can't always separate the method from the cognitive part and
Yes.
just say that is, because it's not. Otherwise, the marks would have been the same. I don't know.
Neither can I, honestly. Neither can I. I know I'm speaking with great conviction over these days about Bloom, but you know, there are times when I look at things and I'm not sure. Actually, I mean, it's interesting to go back and think about what Bloom was up to back in the beginning. Bloom, you know, we're talking about back in the 1950s, and Bloom and his co-workers on that committee, they were firstly focused upon kids in primary school. I think you call it primary school in South Africa, or elementary school in America. Kids, you know, up to about 12 years of age. They were focused on them. That's what they wrote the taxonomy for originally. And secondly, Bloom's motivation, if not the others, was, you know, whenever he went looking in the 1950s or in 40s in schools, he found exam papers which tested the students on facts. Facts, you know, what are the three types of rocks? Igneous, sedimentary, metamorphic, or something, okay? And what he was trying to do with the taxonomy was make teachers aware and examiners aware that there are high-level things that you can ask about. So what Bloom was arguing for was a diversity of questions to be, you know, he was encouraging people to come up with a diversity of questions to test the full range of abilities in students and to make the questions a little bit more relevant to the real world rather than just a dry set of facts. Now, why talk about that? Because firstly, Bloom was very focused on kids in primary school up to about 12 years of age. It's not immediately obvious then that the taxonomy carries directly across to undergraduates at university. It seems to work, but I think sometimes we have to understand that issue and then, you know, use that, be guided a little bit by that when we're trying to place students into or write questions for our students. And the second thing is, you know, I think you said something about the purpose of the taxonomy was to gauge the ability of students, and I suppose that's correct. But again, I'd go back to Bloom. The real purpose of taxonomy is to encourage the examiners to write a variety of questions at varying levels, at the different levels, so that there's a range of things being asked and that we get away from dry, very factual based stuff and move into more sophisticated problem solving type questions. That was a long rambling answer. I'm not sure I actually addressed the comment you made. I hope you got something out of that. I suppose actually I'll go back to what I said, you know, Bloom had his own purposes back in the 50s. The trouble with people like us, and I mean computing people, using something like Bloom is that we in our work, in our day-to-day computing jobs, we like things to be precise, to be unambiguous. Now, Bloom's taxonomy is not designed to be a computer program, to be an algorithm. There is some fuzziness, and we have to accept that as computing people when we apply it. Don't get too carried away with the fuzziness. But, you know, I tried in my answers to sometimes say, well, look, I think it's this and this is why, but I can see why there might be an argument that it's something else. I think you've got to try and be precise as much as you can, but there will be some disagreement. There will be some fuzziness. Put it this way, form a committee of 3 people and the correct category is what 2 out of 3 believe.
Prof, we've got another final question that came up. Somebody made a comment and says, my belief is that the student can be asked questions requiring and operating on a synthesis or create level if they are required to make choices in terms, for example, of how a screen layout should look like. What is your opinion? What is your opinion on the upside down Bloom's triangle, where creating and evaluating and analyzing is on the same top level? That was the comment and then the question. It's from the same.
Where the creating and evaluating. So let's see. So is there 2 parts there? There's let's start with the user interface one. That's a good point. I think that I think that you could ask, if you read the original Bloom book on the synthesis level, you'll find that he spends quite a bit of time talking about essays, because they weren't talking about computer programs back then. They were looking for something where that related to the students, kids of those times. So writing an extended essay where they were arguing for or against something was the sort of thing they had in mind. Now you could present a user interface to the students and say, evaluate this user interface. I think that probably is a question you could put in a written exam. Quite a good question. However, just bear in mind that in the description of evaluate, at least in the original Blooms, it says it's not just, the student is not just expressing an opinion. An evaluation is done against some criteria. And now, of course, there are very good criteria for designing user interfaces. So if the student just wrote us an essay where they said, I like this interface, it's very colorful, it's got this, that, and the other thing, I like that, that's not evaluating. If the student takes some evaluation set of criteria that you've given them and they apply that in their essay to answering the question, yes, I think that is an evaluation question. So I shall have to add another modification to what I've been saying about the written exams, and say that you can ask one about user interfaces. Could you also ask one about, say, the decomposition of a problem into modules? Could you present the student with a heap of code and then say, tell me whether this is this program has been well modularized. In theory, that would be an evaluation question which you could ask. I'm just not sure I could fit it into my exam. The student would have to read so much code. I'm not sure that it's practical, but in theory, that could also be an evaluation question. Now, that was the first thing you said about user interfaces. The second part was, I'm afraid, Bertie, you might have to remind me what the second part was. It was the last.
The second part of the question, what is your opinion on the upside down Bloom's triangle, where creating and evaluating is on the same top level and analyzing?
I'm very comfortable with that. I mean, I must confess I'm a bit confused by the upside down bit, because when you said that, I just imagined the entire pyramid, all 6 levels inverted, and I thought, well, that doesn't sound right to me. But you're just talking. I shall answer this question, then you can tell me I'm answering the wrong question. The issue of the top 2 levels being swapped, I really don't mind that at all. I'm very relaxed about it. The Bloom himself said that although there are 6 levels, they form pairs, and he was very relaxed about the exact ordering. In fact, maybe what he should have done is have the words in each pair on the same line. So there's actually only 3 levels in the taxonomy, and you've just got what, remember, understand on the bottom, then you've got apply, analyze in the middle, and so on. I don't mind anybody. If you have the cognitive skills to say apply well, then you probably have the right cognitive skills to analyze as well. Probably. I mean, I could get into performance versus competence models, which is a concept I don't think we want to get into today. Did I answer the question, or did I answer the wrong question?
Sorry, Ron here.
Yeah.
Good morning. Good evening. It's about the create, evaluate, analyzing be on the same top level. So the pyramid looks like it's upside down with a wider top and a narrower bottom, where you actually put create, evaluate, analyze on the same level.
Create, yeah. So create,
evaluate, and analyze is at the top level, above applying and all the rest to the bottom.
And
but
then everything else is below that.
Yeah, and it seems like it's narrow at the bottom and broader at the top. But we use the Bloom's taxonomy where those 3 levels are actually compressed into 1 level at the top level.
Okay. I would, I'm the classicist in a way, aren't I? I'm the one who reads the Greek, the original Greek, and then argues with people about something. So I'm reading the original Bloom, and I object to putting analyze on the same level as create and evaluate, because by the definition of Bloom, he goes to some pains in the document to say, analyze is a more modest activity than evaluate. So, for example, I think I expressed it on Monday this way, which is, again, thinking in terms of pairs. The analysis process is performed upon, say, a piece of code that the student could have potentially written at the application level. Think of it another way: a student writes the answer to a problem at the application level, and then it's the solution is handed to another student, and that student analyzes it. And we're not talking about, is this a good user interface and so on. We're talking about, well, let's leave it at that for a second. There's not much scope. The analysis is mostly about correctness and so on, issues like that. When we go up to the higher category, the emphasis in create is very much creating. There's a tremendous richness to a diversity to what students could produce. And therefore the evaluation is much more sophisticated. It's not about right and wrong. It's about evaluating the choices that the person made when they created this thing. And furthermore, like I said a little while ago, the evaluation is done against a defendable and established, if you like, set of criteria. It's not a simple judgment about right and wrong. It's much more complicated than that. So I object to that inverted curriculum, I guess, given what you've said.
Thank you so much.
Yeah, I'll digress slightly. Well, I don't know if it's I'll extend. I'll run away with that a little bit. I keep saying that they form pairs. I like that because I was told decades ago by psychologists who worked in that area that if you want people to classify something into categories, he said, don't have more than 3 categories, because people just don't reliably categorize. Groups of people do not reliably categorize to the same category when there's more than 3 categories. And I wish I'd written down the citation that the guy gave me at the time, because it's something I've come back to many times over the years. I feel very comfortable with reducing Bloom down to the 3 pairs, because then I feel comfortable with where I place things, much more comfortable. Once you have many categories, people never agree.